453 in your math workbook. Our objective today is how to identify and classify triangles by size. We're going to be able to describe the differences between equilateral, isosceles, and scalene triangles. And we're going to talk about the vocabulary for those three words in just a second. So let's look at Step It Out. A team of solar engineers is researching triangular solar panel designs. These are three of the design options. How can you classify triangles by their side lengths? Now, you might want to stop right here, and if you have a ruler sitting around, you may want to grab it. So you may want to pause the video and go grab a ruler. If not, you're going to kind of go with me. So for A, they want us to use a centimeter ruler, measure the lengths of the sides of each triangle. So pause the video here and take a second, and you're going to measure each of these triangles. Make sure that you record. For B, they want you to record each measurement next to the correct line segment to the nearest centimeter. So remember, we're going to be using centimeters as our unit of measurement. And you'll notice that they have line segment BC. So you're going to record this first. And for BC, we're going to say that's 3 centimeters. Excuse me. Then we have CD. And that's 4 centimeters. And then DB. And we're going to say that's 5 centimeters. So pause the video here and measure the rest of these triangles and record what measurements you got. Now make sure that you record your side length accurately and precisely. If you don't get the correct side length, you might end up classifying that triangle incorrectly. So make sure you pay close attention to how you're measuring and that you're using the centimeter. We're going to keep writing the measurements and recording. So if you've had a chance to do this on your own at home, then you're going to be watching and making sure that your measurements match mine. So for JK, line segment JK, we're going to say that's 3 centimeters. For KL, 3 centimeters. And then for LJ is 3 centimeters. Okay, and then our last triangle, QR, 3 centimeters, RS, 4 centimeters, and SQ, 4 centimeters. So again, making sure that you pay close attention to those measurements. So thinking about these triangles, what do these three triangles have in common? We know that they all have 3 straight sides and 3 angles. Things that make them different is that all the angles are not the same side or the same measurement, angle measures. So you can see that here with our 3 different groups of measurements that we have, they're not all the same size. So in the next page, we're going to talk about how we can use these measurements to classify these 3 types of triangles. So let's go to page 454 and learn about those. First, let's look at our vocabulary. So let's look at our yellow box and let's talk about what these 3 types of triangles are. An equilateral triangle has 3 sides of equal lengths. Now we know that triangles, they all have 3 sides, but this is what makes them a little different. So an equilateral triangle has 3 sides and they're all equal. An isosceles triangle has at least 2 sides of equal length. And a scalene triangle has no sides of equal length. Okay? So it says number 2, you can identify and classify triangles by their side lengths. Use connected vocabulary to help you identify and record an example of each triangle from your classroom, or in some of your cases, if you're 100% remote, you can use things that you can find around your home or in the world around you. So for an equilateral triangle, one that has 3 sides of equal length, the first thing that popped into my head, because today is pizza day for lunch, I decided to say a slice of pizza. But out in the real world, you might see a road sign, and the road sign would be an equilateral triangle. Isosceles triangle has at least two sides of equal length. And I have up on my wall here in my classroom an ECU pennant. But out in the real world, maybe a boat sail would be an isosceles triangle. And then we have scalene triangles. Scalenes have no sides of equal length. We have here, as part of our math, a tangram puzzle piece. That we could say would be scalene. But in the real world, maybe a skateboard ramp would be a scalene triangle. Let's look at B. Identify and classify the triangle. Write equilateral, isosceles, or scalene. Use a centimeter ruler if needed. So you may have to pull that ruler out again, and you can measure the sides to determine which one of these triangles it is. So for triangle ABC, we're seeing that we have two sides that are equal. So we're going to call this one an isosceles triangle. Okay, for triangle DEF, if you look at all of your sides, you notice they're all different lengths. So we're going to call that a scalene triangle. And then our last triangle, GHI. You can see that all three sides are equal. So this is our equilateral. So why do we classify triangles this way? Well, one reason would be it's based on the number of sides that each length has. And so that's what we use. We use the sides and we use the lengths of each of those sides to help us classify these triangles. So take a second, pause the video, and complete check understanding on your own. So at this point, I'm hoping you've had a chance to do check understanding to see if you understand these three types of triangles. So now let's identify and classify them. Again, you can use a ruler if you need to measure the lengths of each line segment. All right, for our triangle KJL, that would be a scalene. None of the sides are equal in measurement. For triangle STU, notice that all of the sides are equilateral. They're all equal. Oops, excuse me. Now we could also say that this triangle is an isosceles triangle because if you remember the definition of isosceles, it has at least two sides. So we could also label this one as isosceles. All right, and our last triangle, XYZ, is an isosceles triangle. Two of the sides are equal. All right, guys, if you have any questions, don't forget to ask your teachers and make sure you get all of your work complete.